Hello, Honors Algebra 2. I am, as you see, I have my notes up from R5 from our last video. And these notes are just continuing on, so I'm not even going to start it in a new section. I'm just going to continue on. If you were on pins and needles, I did copy it into my spiral, so I'm ready to go now. I just did a super awkward dance there, and very grateful that none of you guys, you're just seeing my hand and not my dance moves. So, okay, we are going to finish R5 today with sum and difference of cubes. So this is a new factoring method that is something that you guys weren't taught in Algebra 1. So let's start there. So sum and difference of cubes. And just like a difference of squares, this one is kind of similar in the sense that there is a pattern. Now this one we can factor it if they're subtracting or if they're adding. Unlike difference of squares, it has to be subtracting. So this one, really what you're looking for are two terms that are perfect cubes. So with that, let's actually kind of lay out our pattern. So your pattern here, I'm going to pick a lovely color for us. And so our pattern here is, so we have two terms, both of them are cubed. So I'm going to use a cubed minus b cubed to start. So over here, I'm going to do it as a cubed minus b cubed. And then what I'm actually going to do on the right-hand side, I'm going to do an example with numbers that you might be more familiar with. So I'm going to do x cubed minus 8. Now, before I do anything, both of these terms are cubed. 8 cubed, the cube root of 8, no, I'm sorry, a cubed, letters, words. So the cube root of a cubed is a. The cube root of b cubed is b. The cube root of x to the third power is x. The cube root of 8 is 2, because 2 times 2 times 2 is 8. So we'll start. So the pattern, the first thing I do is think, like I already had said, what is the cube root of each term? So the cube root of a cubed is a. So I'm going to rewrite it as a cubed. I know it seems a little silly right now, but just bear with me. So what we're looking at are those singular terms, like the cube root of each of those terms. And so that pattern is going to be, so my first term minus my last term. So my first term minus my last term. And we'll talk about the signs in a second. Times my first term squared. So a squared plus my first term and my last term multiplied together. So a times b plus b squared. So the last term squared. So let's actually use this. And again, I'll talk about the signs in a second. But again, let's use that pattern to help us with x cubed minus 8. So the cube root of x cubed is x. So I'm going to rewrite that as just x cubed. And the cube root of 8 is 2. 2 cubed. So my pattern, it's the first term, so x, minus my last term, 2, times my first term squared, so x squared, plus my two terms multiplied together, so x times 2. Now we don't really write it like as a term as x2. We write it as 2x plus 2 squared. Now 2 squared we can simplify to be 4. But if you need that reminder, that was just 2 squared. Okay, now let's talk about the signs, because it does change if this number in between is plus. So we have an acronym that helps us to actually remind ourselves of the signs. So the first one is always going to be the same sign. So let's actually write it in green. So it's the same sign. So we're going to use that S with our acronym of S. Okay. So the first one is always the same sign. If it's a minus, it's a minus, minus, minus. Okay, this one's the opposite sign. So we're going to use O. So if it's a minus here, it's going to be a plus here. Minus here, it's a plus here. And we'll do an example with a plus in a minute. And then this last one, always positive. So we use the acronym SOAP. And sometimes you'll hear me reference this method as the SOAP method. I don't know why, because it's not really talking about the method. It's just talking about the signs, but sometimes they say that. So if we look over here and we look at this last part, I would think to myself, can I factor that further? Do I know two numbers that multiply together to get me 4 and add to get me 2? I don't. So I'm going to leave that, and that is my final answer. As just like a word to the wise, you'll never be able to factor this last one. It will never be able to factor further. So there you have it. You don't ever have to really think about it more. Okay, let's get into some more challenging ones. So I did 10. It was my last one. So I'm going to do 11. And I'm going to try and I don't know if this is going to work. If I'm going to be irritated with this. Okay. So 11. Okay, so we have 8x cubed plus, so I'm going to change up the sign, 27. Okay, so our first kind of check to ourselves is 8x cubed a perfect cube root? And the answer is yes. And then is 27 a perfect cube? And the answer is yes. And so I think, okay, so what is the cube root of 8x cubed? And it's, hopefully you're thinking about it on your own. If you need a second pause, spoiler alert, it's 2x. And then I'm thinking, what's the cube root of 27? Thinking it's 3. 3 times 3 times 3 is 27. Okay, so now's the setup. Okay, so it is always starting with the first term. Same sign. So if it's plus, it's plus. The second term. First parentheses, done. Second parentheses, let's go. Okay, now it's the first term squared. So I'm going to do this in a second on the side, but the first term squared, that's 2x squared. The biggest issue that people have is not squaring that entire term, just squaring the variable. You're squaring that entire term, that entire expression, 2x. So it's 2 times 2, which gets me 4, and x times x, which is x squared. So again, what you're doing there is you are doing 2x squared. Now my sign, opposite sign. If it's positive, we're going to make this negative. Then multiply the two terms together. 2x times 3 is 6x. Again, let's write that out so we don't forget what we're doing here. And then last sign, always positive, the second term squared. So 3 squared is 9. Is 3 squared. And that's it. That is your final answer. And that, remember, this one will not be factorable. If you don't trust me, you can try and factor it yourself and see if you can factor it. Okay, so I'm going to have you guys try one on your own. So let's do that. So we have, let's see, number 12, x cubed plus 729. So x cubed plus 729. So I want you guys to first just think of the cube roots of each of those. So what are the cube roots of x cubed? What are the cube roots of 729? Okay, so hopefully you're thinking the cube root of x cubed is x, and the cube root of 729, is 9. Now, if you don't know that off the top of your head, you can always go into your calculator. Oops, we're losing. I should move my document camera down a little. Maybe that will help. No, I have to move the arm forward. That was like a dumb spatial thing for me. Okay, there we go. So we can use our calculator. And if you go into math and down to the fourth one, where you see that cube root looking thing, you can type in the cube root of 729, which is 9. So you can always get the cube root of one of these numbers using that. Let's again math. 4. Type in any of your numbers. Oops. Notice how I accidentally put in a plus? I can just delete it and enter, and it will give it to me. Okay, so then I want you guys to try and use the pattern to factor this one. So pause me right here, try and factor this one on your own, and then come back and make sure you did it correctly. Okay, hopefully you're coming back. So we have x, same sign, plus 9. So first term, last term. First term squared. Opposite sign, so if this is a plus, this is going to be a minus. My terms multiplied together, so x times 9, which is 9x. Always positive. My last term squared. 9 squared is 81. And that is it. Okay. Again, remember, as you guys are going through this, if you guys have any questions or like you're feeling like, this isn't making sense, you guys can always write your questions down and then bring them to class and we can go over them in class together. So great tool. That's what that's for. Okay, so I'm going to give you guys 2 more. I want you guys to try this one on your own. So I'm going to give you, let's see. Oh, hold on. I just got a text message that I had to respond to, so I'm back now. Okay, so we are going to try this one. 64 x cubed minus 125. Okay, so what I want you guys to do is first, just on your own, think of what's the cube root of each of those terms. So what's the cube root of 64x cubed? What's the cube root of 125? So try those first, come back, check your work. Okay, so I cubed rooted mine. So we got 4x cubed is 64x cubed, and 5 cubed is 125. Okay, so now what I want you guys to do is try and pause me here, try and factor this one on your own using the pattern, and then come back to check your work. Be careful, take your time. Use 11 like as a resource to help you, and then come back and see how you did. Okay, you should be coming back to check it. So it's going to be first term, 4x, same sign, minus last term. Okay, pretty straightforward. The first one's always the easiest. Okay, now my second one is always my first term squared. So that's 4x times 4x. So that's 16x squared. Then it's my opposite sign. Then it's the 2 terms multiplied together, so 20x. Always positive, 5 squared, which is 25. And again, if you need those little hints to remind you, this is 4x squared. This is my 2 terms multiplied together, 4x times 5. And this is 5 squared. And that is your final answer. Okay, the last one, let's make this like a little bit more challenging here, is going to be 14. So we have 27x cubed plus 64y to the 6th. Whew. Okay. Now, first thing I want you guys to do is just think of what's the cube root of each of these. So what's the cube root of 27x cubed? What's the cube root of 64y to the 6th? Remember what we talked about before and that little hint. The cube root is the same as a fractional exponent of 1/3. So you can use that with the y to the 6th. Okay, so you should be coming back. You should have thought about what's the cube root of both of these. Now this one's pretty straightforward. It's nothing different than what we've already been doing. It's just 3x. Now we know the cube root of 64. We actually did it over here. The cube root of 64 is 4. Now the hard part here is what's the cube root of y to the 6th? Now let's actually talk about that. So the cube root of y to the 6th. Now what I was saying is, remember, it's the same as a fractional exponent. It's the same as me taking y to the 6th and raising it to the 1/3 power. And then hopefully you remember, if you don't, we'll be talking about it in a video soon. 6 power to a power, we multiply. 6 times 1/3 is y squared. So the cube root of y to the 6th is y squared, which if we look at it here, makes sense. We would distribute this 3 to the 4. 4 cubed is 64, and then with power to a power, 2 times 3 is 6. Okay, so now I want you guys to try and factor that one on your own. Come back, check your work. Sorry, you didn't see that side point here. Come back, check your work, see how you did. Okay, you should be coming back to check your work. So the first term, 3x, same sign, so plus. Second term, 4y squared. And then it's my first term squared, so 3x times 3x, which is 9x squared. Opposite sign, so if this is a plus, this is going to be a minus. My two terms multiplied together, so 3x times 4y squared, which is 12x y squared. I don't care what order you put those in. I usually just do it like whatever term is first and whatever term is second. So x first, y second. And then always positive. My second term squared. So 4 squared is 16. Y squared squared is y to the 4th. Again, let's write those little like reminders below if you need them. So this is 3x squared. This is 3x times 4y squared. And this is 4y squared squared. And that is your final answer. And that does it for sum and difference of cubes. So the biggest thing that you need to have remembered is the pattern and the signs. So I use SOAP to remember the signs, same sign, opposite sign, always positive. And then the pattern, I just like, honestly, it's the first term, last term, first term squared, first and last term multiplied, last term squared. So come to class with questions if you have them. And that is it for this section. Have a great day, guys.